Welcome back. In this lesson, we're going to look at the hardness of minerals. Hardness has several different ideas attached to it. A hard mineral has something to do with the exact design of the crystal. So the bonds of the crystal within the crystal to each other can determine something about its hardness. For instance, can it break apart? If you were to hit it, would it shatter into 1,000 pieces, or would it bend? Would it be like elastic and take that force and then restore back to its original shape? Or would it crack along a certain ridge? And if it does crack, where does it crack? Does it crack along a certain line or no line? Okay, so the hardness would also depend on whether or not you can scratch that material, or whether you would use that mineral to scratch something else. So hardness has a lot to do with the design of the crystal, what the bonds are like between the crystal and the next crystal over, and it has a lot to do with whether that mineral is made up that makes up a rock is going to be a durable hard rock, or something that you could break with your fingernails, which there are minerals that you can do that. So let's look at all these together. So the strength of a rock has a lot to do with what it's made up of, and the strength of what it's made up of, these minerals that comprise rocks, has to do with the strength of its chemical bonds. So the bond between one atom and the next, or between one atom in a crystal and the next crystal over, or depending upon the repeat in the pattern, has a lot to do with how a mineral will break, and then how strong is the rock that these minerals make up. Okay, so when you're talking about earthquakes and the breaking of rocks and the shattering of rocks, it has a lot to do with what it's made up of. So studying these minerals can then help you in other questions, bigger questions that we might have later. The first term is a word called tenacity. Tenacity, I've never really think of it in terms of minerals. I know that you have the tenacity of a mineral, but tenacity usually has the idea of that I keep going, that you can't break me, that I just keep bouncing back. So even though that I might lose and lose and lose, I just keep trying, keep struggling. That's tenacity. So something that's tenacious, a mineral that would be tenacious, has a resistance to breaking. So the harder that a mineral is, you hit it with a hammer, the less likely it's going to break, the more tenacious it is. So the tenacity has to do with breaking. It also has to do with deforming. If you think of clay, okay, which has lots of water in it, so it's just basically minerals together kind of in a matrix. You hit clay with a hammer, you're just going to leave a dent in the clay. It's going to deform and then have a new shape based upon that deformation. So that is a type of tenacity. Do you have a malleable, or do you have a bendable or an elastic tenacity? That is the type of mineral you have. So you can have a malleable, especially metals would have a malleable tenacity. So if you hit it, you could hammer it into a sheet, or you could pull it into a wire. It would be ductile or malleable. Sectile is anything that you can separate. So if something like slate rocks, which have certain minerals in them that are strong in one direction but weak in another direction, you can break them into tiles and use them to tile your roof, because they make nice flat tiles. Elastic minerals, and we mentioned clay, is one that would bend or misshape if you were to strike it, or if it were under stress. So something that's elastic could bounce back, but something that is very brittle, like say an ion bond like table salt, would not hold. I'd hate to have a column made out of salt, because it would be very shatterable. You could take the back of your spoon and grind that table salt into powder, because it shatters, because it's a brittle material. The next thing we're going to talk about is hardness. So make sure that you clear that in your mind. Hardness is not resistance to breakage, because that's what tenacity is. Hardness has a resistance to scratching. So if you were to take your fingernail, you could scratch some minerals, but those minerals would have would be softer than your fingernail. Your fingernail has a certain hardness. So certain things could scratch your fingernail, other things could not. If you had something like talc, which you make into baby powder, talc is a mineral, but talc could certainly not scratch your fingernail. In fact, you use small minerals like that to put a gloss, say, on a mirror or on a glass countertop or something like that. So something very, very soft won't scratch something that has a higher hardness number. The numbers are based on Mohs scale, and Mohs scale is 1 to 10, with a diamond being a 10. So diamond being the hardest substance, where nothing can scratch a diamond except another diamond, and a diamond could scratch all other things. So just as a kind of a basis, your fingernail has a hardness of 2.5 out of 10, but a penny has a 3.5. So you could not scratch a penny with your finger. You could take a piece of copper and scratch your fingernail, okay, because it's harder than your fingernail. Glass is about middle of the road, about 5. So lots of things can scratch glass, but glass doesn't scratch a whole lot of things, only the very soft materials. And then there's a layer, and all minerals are put on this Mohs hardness scale. So here's some representative minerals in this scale. I already mentioned talc, which is baby powder. It has a 1. Gypsum, which is in sheetrock, it's in wallboard, is a 2. Calcite, about a 3. So calcite, you're going to see lots and lots of different kinds of calcite. And fluorite, very similar. Fluorite will glow in the dark. It's a fluorescent material. Apatite, orthoclase. Quartz, a lot of people would recognize quartz. It's the white shiny stuff that's in granite. So if you have a granite countertop, the quartz is the white sparkly stuff. Topaz is actually an orange stone, like a gemstone. Corundum, mostly used in industry to grind things. It's a lot of times on grinders, is very, very hard. And then the very hardest substance is a diamond. And you can have industrial diamonds also on saw blades and grinders that will make cutting something easier. I did want to mention that these are simply not stronger, but it's a logarithmic scale. So every one is a lot more than the previous one. Okay, so when you say get from topaz to corundum, topaz about an 8, topaz about a 12, corundum about a 20. That's a lot different than, say, talc to gypsum. So as you go up the scale from 1 to 2 to 3 to 7 to 9 and up to 10, it's increasingly harder and harder to scratch. So diamond being, from 20 to 40 times more resistant to scratching than a 9 would be. So 10 is many, many times more than a 9.